Hi friends, this is Dr. G. Srinivasa Gupta, Professor from Department of Mechanical Engineering of JYOTHI Institute of Engineering Technology. As a part of Dynamics of Machinery course, today we are going to discuss a concept on balancing of radial engines. As this radial engine means is a multi-cylinder engine in which all the connecting rods are connected to a common crank, single crank, all connecting rods. This is multi-cylinder engine. Cylinders are placed circumference of in radial direction. That is, it's called radial engine. The analysis of forces in such type of engine is much simplified, and also complete balance is possible. So how we are going to analyze is using the method of direct and reverse crank approach. So all the forces in the same plane are balanced, no unbalanced couples exist. Okay, forces as well as couples will be balanced, right? Because it is single plane, no couple does exist, and as forces are going to be balanced by using this approach of direct and reverse crank. How it comes, let us see. In reciprocating engine, what are the unbalanced primary forces? We know that along the line of stroke, mr omega square cos theta, we have seen. We try to balance these forces, and we have seen there is an effect of a hammer blow. So we come to a compromise that partial amount of reciprocating masses can be balanced. Okay, the effect of which remaining unbalanced forces we have seen tractive force and swaying couple in multi-cylinder engines. So anyhow, in case of radial engines, this method of direct and reverse cranks, a force identical to this force is generated by two masses in the way, means a mass m by 2 at the crank pin A. Suppose this is crank is rotating circular clockwise. This is the shaft. Anyhow, this is the crank. Orientation with the center line is this crank is theta now. Then this is, let us say, OA is the crank position. Then what we can do is we can attach the mass to balance this mass. This is mr omega square cos theta, primary unbalanced force because of piston reciprocity. So we can attach the mass here m by 2. This is a crank, and also a mass m by 2 placed at the crank pin in the imaginary crank OA dash. Exactly theta in opposite direction. This is the theta. This is the OA dash. Imaginary crank we can attach same. This is whatever it is also same. These two. But imaginary crank in opposite direction of the rotation of this one with the center line, same angle. Then what happened here also, m a dash, this one m by 2 mass we are going to attach. Then so we can see that along the line of stroke we have two components of this balanced mass we have attached. This is m by 2 r omega square cos theta, m by 2 r omega square cos theta again here, along the line of stroke. Then this could be balanced, and this unbalanced, because of attaching this mass, there is an unbalanced force, that is centrifugal force, which is perpendicular to the line of stroke. Because of these two cranks, direct and reverse crank, this can be nullified. There is no unbalanced force. So as we say, a mass m by 2 placed at crank pin A and rotating angular as omega in direction. Also a mass m by 2 placed at crank pin, imaginary crank at A dash, and same angular position of the real crank in the opposite direction. This is angular position omega. This is rotating obviously in opposite direction omega. That's why it is opposite direction of line of stroke. This imaginary angular position is at opposite direction line of stroke. Okay, this imaginary crank is assumed to rotate in the same angular velocity omega in the opposite direction. Okay, this is in this direction, suppose rotating, this is in opposite direction. So that while rotating, the two masses coincide on the cylinder center line. Now the components of centrifugal force due to rotating masses along the line of stroke are, you can say, due to mass A, MRO, M by 2 R omega square cos theta, due to mass at A dash, M by 2 R omega square cos theta. Thus total force along the line of stroke becomes MR omega square cos theta, which is equal to the primary force, which is unbalanced force, then it could be balanced. At any instant, the components of the centrifugal force of these two masses normal to the direction is equal and opposite, so there is no unbalance in perpendicular direction to the line of stroke. The crank rotating in the direction of engine rotation is known as the direct crank, and imaginary crank obviously it is rotating opposite direction, known as reverse crank. This is reverse crank, OA dash, OA is direct crank. Okay, now coming to the secondary forces. Secondary forces, similar way, it is let us say this crank is making an angle here. Okay, this is the center line. Then okay, I will draw here. Okay, this is crank is making an angle 2 theta here, direct crank, and imaginary crank also in the opposite direction making 2 theta. Are able to, okay, this is let us say A1 dash. So this is rotating, what is the velocity? 2 omega. Here also it is rotating in opposite direction, 2 omega, imaginary crank. So what happens? Secondary accelerating forces we can see this is because these are going to give mr omega 2 omega square cos 2 theta by 4n we will write, because it is 2 omega we have written. This is, we can say that r by 4n, length of the equivalent length of crank, here also r by 4n. Then we can write m r by 4n 2 omega square cos 2 theta. This is 2 theta. So these two components along line of stroke, sum becomes m r by 4n 2 omega whole square cos 2 theta. That is, okay, m r omega square cos 2 theta by n. This is unbalanced primary force, which is can be balanced, because unbalanced primary force, you know that this is could be balanced because of two direct and reverse cranks. This is secondary accelerating force. This can also be generated by two masses in similar way. That is, okay, this one. Okay, understood? Right? Direct crank, reverse crank, 2 theta initial angle of direct crank, opposite direction it is rotating with 2 omega, reverse crank also, OA 1 dash. So the line of stroke, along the line of stroke, the force, which centrifugal force which along line of stroke of these components of direct and reverse crank giving is equal to required balanced secondary, required to balance required amount of secondary unbalanced force. Okay, it's all right. Then let us take one numerical example. This is the 3 cylinders of an air compressor have their axis 120 degrees each other. How these 3 cylinders? This is one cylinder. Okay, this is piston and a cylinder, and this is second one, this is third one. Let us say second one, second cylinder. Okay, this is a piston and a cylinder, right? And this is piston and a cylinder, third one, right? Okay, then the cranks of these three is, okay, it is radial engine, means obviously the crank is single and it is rotating about attached to the shaft and rotating. This is 120 degrees, you know that, 120 each other. The cylinders, these are cylinders, center line of cylinders. Okay, you have seen this is one, this is two, third one, center line of cylinder. This is, okay, the cylinders are placed. This is the connecting rod, this is connecting rod, this is connecting rod, and center line. Okay, if you join with the shaft, then this is, okay, this is 120, cylinders are placed 120, this is 120, this is 120, this one here. Okay, this is 120, 120. This is the crank, right? This one. Oh, let us say O dash crank. So now What is that? Place 120 or a single crank. The stroke is 100 mm. Okay, from the stroke you can know the radius of the crank is stroke is 2r. So radius of crank is 100 by 2. So that is 50 mm radius of crank, 0.05 meters. And what else is given? The length of the connecting rod is 150 mm. L is 150 mm. 0.15 meters. Then the mass of the reciprocating parts per cylinder is 1.5 kg. Per cylinder reciprocating masses is 1.5 kg m. So find the primary and secondary forces acting on the frame of the compressor when running at 3000 rpm. Describe clearly the method by which such forces may be balanced. What are primary forces? What are secondary forces acting on the compressor frame? Then how we are going to balance? We have seen the position of 3 cylinders. This is the figure drawn, and let the common crank be along inner dead center 1. This is common crank along this cylinder 1. This is 1, this is 2, this is 3 cylinders. Okay, along this common crankage is this orientation, let us say. Then some common crank rotates clockwise, therefore theta is positive and measured clockwise. Because it is, let us say, it is rotating clockwise, common crank generally, so theta is clockwise is positive, let us take. Then how we are going to write primary balancing forces? So this is, see this, these are 120 degrees orientation. Then we can see that maximum primary force acting on the frame of the compressor. How we can calculate? The primary direct and reverse crank positions we are need to understand. So first cylinder, because theta is 0 for cylinder 1, therefore both primary and direct and reverse crank will coincide with each other, because we have seen this is cylinder 1, primary crank, opposite direction. This is let us say center line, this is the angle making, then opposite direction, this is the angle. These two are coinciding. This is 1. Okay, understand or not? Okay, here this is along the center line, this is coinciding 1. Then because since theta is plus or minus 120 for cylinder 2, therefore primary direct crank is 120 degrees clockwise, as you understand, because primary and reverse crank for cylinder 2 is, it should be 120 degrees positive clockwise direction primary, and minus 120 is anti-clockwise direction from its position. So that is 120 positive. Primary crank is obviously primary crank 120. From here 120 positive means here itself is primary crank position. Okay, I am talking about primary positive 120. Now coming to the third cylinder, it is 240 from its position clockwise. I am talking about primary crank. Reverse crank I will come that point. This is 240, because 240, so this is 120, 120, 240. So primary cranks of all cylinders positions, it must be in this primary. Okay, now coming to the secondary, this is primary crank rotating with the angular velocity omega, as you know that their position is along the line of action. Now secondary means cylinder 1 is you see that because it is coinciding reverse crank, so for cylinder 1 this is itself in this direction only, cylinder 1. But cylinder 2 minus 120 opposite direction, it should rotate anti-clockwise minus 120, means this is cylinder 2 position reverse crank. And this is third cylinder, it should rotate minus 240 in anti-clockwise direction. Then third crank of the reverse crank of the third cylinder is this one position. Are you able to understand? This is reverse crank position, reverse cranks, imaginary cranks position. This is primary crank position. Now that is direct. We can say direct. This one primary. Reverse means you can say secondary or reverse. Okay, only. This is direct and reverse, you can say. Okay. Now coming to, because of position of these 3 cylinders and each having total mass to be balanced is mass of each cylinder, reciprocal mass is m given. Then how do you calculate primary unbalanced force first, then this reverse crank obviously is going to give balancing effect. So we will see that, okay, we see that primary reverse cranks for a balanced system. This is primary reverse cranks, okay, we have seen. And also there is therefore there is no unbalance of primary force due to the reverse cranks. From figure this you can see that, okay, because these will be going to be balanced. Primary, there is no unbalance because all are in this direction, okay. And say reverse cranks, if you see, we see that the resultant primary force is equivalent to the centrifugal force of mass 3 times m/2 attached to the end of the crank. Okay, primary m/2 only, we are going to attach primary m/2, secondary m/2. So 3 times m/2 attached to the end of the crank in each case, okay, primary, direct cranks and reverse crank. So how do we calculate this one? So maximum primary force, what is that? Always we are going to distribute the mass of reciprocating masses in each cylinder is primary half and secondary half. Primary is m/2. So what is the primary force coming because of this crank rotation and mass attached at end of the crank, direct crank, let us say. So 3 into m/2 omega square r, you know that, calculate that one. That is the primary force, unbalanced force which could be balanced because of reciprocating masses which is unbalanced in this. Then by attaching the masses to the cranks primary, we can balance it. The maximum primary force may be balanced by the mass attached diametrically opposite to the crank pin and rotation with the crank of magnitude. We can say how much balancing mass with the radius required. We can say that the balanced, how much mass we are going to attach and what is the radius. Let us take magnitude of mass is B1 and at a radius B1 distance, such that BB1 must be 3 into m/2 r, because omega is same, okay, opposite or reverse or direct rotation, omega is same. So this is the primary force which could be balanced, and the mass how much required to balance with radius, the product, it is directly calculated here, B1 how much we need to attach. This is this one, this attachment, how much we need to do this one, okay, understand or not. And reverse also m/2 and direction, okay. So now coming to the secondary. So maximum secondary force acting on the frame of the compressor, how we can calculate? As we have seen here, 2 theta, crank is rotating with 2 theta, then we can see that, okay, the crank's position of each cylinder required, primary case. When sin theta is 0 and 2 theta is also 0 for cylinder 1, therefore both secondary, direct and reverse cranks will be coincide with the common crank, that is because theta is 0 first cylinder, so this one only. Then coming to second one, okay, this is theta is plus 120 for the primary crank or direct crank. Then 2 theta here, 2 theta means 2 into theta plus that is 120, 240. 240 means initially it is, the second is this one, from here 240 clockwise. Clockwise 240 means, okay, here it becomes this I will show you this initial position. This is 2 clockwise 240, it will come here. Are you able to understand? 120 here and 120 clockwise, positive, direct crank. Are you able to understand? So we need to see, this is second is in this position. This is I am talking about this secondary force balancing, and how much secondary force is unbalanced. That is, you know that m r omega square r by, we will write generally m r by 4n 2 omega whole square into cos 2 theta. That is the unbalanced force. So these cranks, direct and reverse cranks, need to be balanced, that one. So each the position cranks we are going to attach m/2 only. So position we are going to talk about. Direct cranks, it is first one is because it is 2 theta, first one is anyhow coinciding with the initial original crank. And second cylinder, this is plus 120, 2 theta means plus 240. So it should rotate clockwise. That is, its position is this. Okay, the direct crank position of cylinder 2 mass. Okay, mass attachment on the crank. And third one is plus 240. Plus 240 means 2 into 2 theta, 2 into 240. Okay, it means 480. 2 theta means third cylinder I am talking about. So it is 480, it becomes, means 360 plus 120. It should rotate clockwise 120. Original position is this one, 120 it has to rotate, it will come in this position. So this direct crank is, for third one is here. This is the position. Now coming to the reverse crank. Reverse crank, this is direct crank position, direct. 2 omega it is rotating, let us see 2 omega, because this radius of crank is also r by 4n each crank. Okay, it is 2 omega. That's why you can see that mr by 4n 2 omega whole square cos 2 theta. This is the written. R equivalent to r by 4n. Omega is 2 omega square. This becomes mr omega square cos 2 theta by n. So this is our secondary force, unbalanced force. This we are going to balance. At each crank end, we are going to, at each crank end, we are going to attach. Okay, I will draw again here. We are going to attach this one, primary this one, we have already seen. This secondary, I am going to see here, this is direct cranks, and this initial first crank is, okay, 2 theta means 0 only, coincide with original crank. Second one is 120, means 240 it has to rotate clockwise. That means secondary position it is. Original is you have seen, original I will draw here. Second this one, third this one, first this one. First any of 2 theta 0. Second is should 120. 2 theta means 240. It has to come to this position. Third one 240 into theta, that is 2 theta means 480. 480 means 360 plus 120. It has to rotate 120 clockwise. So third becomes here. Direct cranks. Now talking about reverse cranks. Reverse cranks means first one anyhow it is 1 because 2 theta is 0, and second one 120 means 240 it has to rotate anti-clockwise. Initially its position is here, 240 means 120 240, so its crank position here only. Then third one 240 means 480 okay, that is 360 plus 120, again it has to rotate 120. This is reverse cranks I am talking about, reverse crank 120 anti-clockwise, because initial position is this one 120 if you rotate anti-clockwise. So these are the reverse cranks. Reverse cranks all are coinciding with its original crank position. Are able to understand, I think. Then maximum secondary force, you know that each crank and we have attached m by 2 mass. So maximum secondary force is, it is rotating 2 omega, as you know that here also 2 omega, okay, primary and secondary. Then 3 m by 2 omega whole square, that means mr omega square. R is r by 4n, you know that r by 4n, okay, direct and secondary cranks. So m3 into m by 2 times mass 2 mr omega square. Maximum force we are talking about means theta is, okay, cos 2 theta at crank angle position in line with the cylinder center lines. Then this is that components along the center line. 3 m by 2 into 2 omega square r by 4n, 3 times. Okay, 3 into, okay, if you calculate, you are going to get, okay, 3702 newtons. This is the maximum secondary force which is acting on the frame, which could be balanced by attaching masses and crank positions, that direct cranks and secondary, or we can say reverse crank positions are like this. This I think you are able to understand how this crank orientation is going to be understood. Okay, is it clear? I think. Then this maximum secondary force may be balanced by, let us say we are having a mass at B2 at radius B2, let us take each mass B2 and radius at B2 attached diametrical opposite. How much mass we are attached? We know that m by 2 only attached, but that product of mass, because radius you can change, that's why it is again calculating product of mass attached into radius. If this is vary, you can vary. This is equal to, you know, that 3 into m by 2 r by 4n. Okay, this you can substitute. Okay, m each cylinder 1.5 kg reciprocal mass, and r by 4n. N is L by R, stroke connecting rod length by radius of the crank. So you will get this value B2 means what do we need to understand is, here the masses generally we said m by 2 we are going to attach to bring it to the balance of the mass total unbalanced force, primary or secondary. If you say, if you want to just consider the crank, the balancing mass attached to the crank at some other radius, then mass you need to vary. That's why this product is calculated. Here we are going to get its value is 0.009375 Newton meter, because it is MR value. Okay, MB, RB you can say instead of this writing if you have any confusion. This is balanced mass at the balance radius RB you can attach, that is equal to this. That right side quantity should be satisfied. Okay, for all these, okay, masses together MB. Understand or not? Okay, so if you vary crank radius, this mass also going to be varied. With this balancing of radial engines, it is very simple and straightforward, and there is no unbalanced couple. Reason is all the forces are acting in single plane. Okay, here we have seen this problem as 3 cranks 120 degrees each other, 3 cylinders 120 degrees each other, position center lines. But if as many number of cylinders as we have, then accordingly we have to take the mass distribution, and we can give the analysis part. Okay, with this I am concluding this lecture here. We will meet in our next lecture. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.